If you always follow the same path, you will always get to the same place. This adaptation of the famous phrase does not fit our project at all, given that our steps have always been following our discovery in a different direction to that of the majority of companies that are producing green hydrogen or have in mind to do so. When in 2011 we produced synthetic fuel instead of bio-oil without adding hydrogen to the process, we started our own way by studying what, why, and how we can reproduce and improve it. It has taken us a long time to figure out the what, obtaining the hydrogen radical with a catalytic thermolysis process, with a catalyst designed by us. More time to know the why. Why do we need almost no external energy input? Thanks to the different reactions that take place at the same time in the process, we achieve after an initial energy input that the working temperature and pressure enter in a stationary state and the process is maintained. Why is the cost lower than other processes? For the same reason, if we do not provide energy, we have no cost beyond the activation energy in the activation pumps. Why can we have distributed production? We can produce alongside the raw materials to be treated in the case of the production of synthetic fuels, such as CO2 emitters or sewage sludge, or also customers who require green hydrogen for their industrial processes, thanks to not needing auxiliary investments such as wind turbines or solar parks or deionized water. Our water can even be water from sewage treatment plants. Why can we scale up to the customer's needs? Our system can start from a plant of 100 tons of hydrogen per year, up to the desired amount, or we can adapt to the needs of the waste-generating customer to be able to treat the amount produced without having to move waste feedstock over long distances. How? Up to 53 gas phase reactions take place in the process, some of which are exothermic, producing enough energy to keep the process running continuously. One of the reactions is the formation of hydrogen gas, allowing this molecule to be obtained in a clean form and without greenhouse gas emissions. How do we produce synthetic fuel? Thanks to the high reactivity of the hydrogen radical, if we add carbonaceous elements to the process, we can form hydrocarbon chains, liquid or gaseous, with zero net emissions for immediate use in aviation, heavy transport, or shipping. How can we improve the process? Our technology has already achieved a previously unattained milestone of producing liquid synthetic fuel, diesel, from wet biomass, without hydrogen input and without expensive and rare catalysts. We are in the final phase of characterization of our catalyst, and having complete information will allow us to design and optimize both the catalyst production process itself and the process of obtaining end products: hydrogen, diesel, SAF, methane, plastics. We have a laboratory equipped with scale reactors, control and analysis elements, a pilot plant ready to become an MVP, and the human team that started this adventure with more enthusiasm than when the discovery was made. All these years, we have seen the guidelines of the governments to achieve a sufficient decarbonization of the planet to stop the deterioration of our transport across the universe, where 8 billion passengers travel and the solutions provided only cover part of the problems. Our innovation comes to be able to attack the problems head-on. It offers adaptable solutions to different challenges and has the right cost to be extended to any part of the world that needs clean energy. And that requires a transition in line with our economic interests in the provision of services to the people of the area. It is not a solution unless it reaches all corners of our world and benefits all its inhabitants. Hydrocarbon engineering.